Good morning, students. Today we will discuss the third part of heat treatment, that is surface hardening. So, in all the type of heat treatment, we have to conduct three stages. First, we have to heat the material to certain temperature, hold that at that temperature for certain period, and then cool the part at a particular cooling rate. So, variation in these processes form different microstructures, and depending on the requirement, different type of heat treatment processes are chosen. So, this surface hardening is another type of heat treatment process. In order to possess considerable strength to withstand forces acting on them and to withstand wear on their surface, the parts must be made of tough materials and provided with a hard surface. If the total thickness will be hard, then it will become brittle. So, in some cases, we require to make the inner side of the material tough, but the surface is to be very hard. In this case, the surface hardening process is chosen so that it will result a inner tough material and outer hard surface. So, this surface hardening or case hardening provides us a hard and wear resistant surfaces, close tolerance in machining parts, and tough core combined with a higher fatigue limit and high mechanical properties in core by introducing carbon or nitrogen on its surface with core remaining soft. As I have already told, we have to harden the surface. So, this is achieved by adding carbon or nitrogen to its surface up to certain depth, and the core is remained soft. So, what is the advantage? As the core is soft, it is tough with high mechanical properties and higher fatigue limit. And as the surface is very hard, it resists wear and tear. So, different type of surface hardening processes are carburizing, nitriding, carbonitriding, cyaniding, induction hardening, and flame hardening. So, by adopting any one of the method and considering the material, the method is chosen. Carburizing. It is the process of producing a hard surface on low carbon steel parts. We have already discussed low carbon steel, high carbon steel, medium carbon steel. So, if the material is low carbon steel, surface hardening is done by carburizing. In this process, the steel is heated to 870 degrees centigrade to 950 degrees centigrade. So, first you have to choose the temperature. In this case, the temperature is 870 to 950. At this elevated temperature, carbon is infused into the surface of steel by diffusion from carbon monoxide gas. There are three methods of carburizing. 1. Pack or solid carburizing, 2. Gas carburizing, and 3. Liquid carburizing. So, pack or solid carburizing, in this process, in the first stage, the metal is enclosed in a cast iron or steel box containing a material rich in carbon. So, it is a solid carburizing. So, we have chosen a solid material which is rich in carbon, and the metal is enclosed in a steel box containing this material rich in carbon and heated to a temperature slightly above the critical point and allowed to remain at that temperature for a sufficient time and then allowed to cool slowly within the box and then removed. So, cooling rate is very slow. It is kept within the box during cooling. So, in second stage, the metal is reheated to about 900 degrees centigrade. So, first it is heated, cooled very slowly inside the box. But in the second stage, when it is cooled inside the box, again it is heated to temperature 900 degrees centigrade. But this time it is quenched in oil. Remember, quenching in oil produces a very high rate of cooling. So, with very high rate of cooling, it is cooled down so that its structure is refined, brittleness removed, and the core becomes soft and tough. The metal is then reheated to about 700 degrees centigrade. In the second stage, the core was affected. The structure, that entire structure was refined. So, core was soft. In the third stage, it is reheated to 700 degrees centigrade and quenched in water or oil to obtain hardenability of the outer casing, which was softened during the preceding operation. In the second stage, both the core and the case, everything was softened. So, to hard the outer case, it was again reheated to 700 degrees centigrade and quenched in water or oil. So, this is all about solid carburizing. Next is liquid carburizing. For liquid carburizing, liquid salt bath of cyanide, chloride and carbonates are prepared, and the parts to be case carburized immersed in them. So, in a container, this salt of cyanide or chloride and carbonates are kept and the part is immersed. Heating of the bath is done by means of electrodes immersed in the bath by supplying electricity. So, stirring of the bath is necessary to ensure uniform temperature. If the entire component is to be carburized, then no additional treatment is necessary. But if only some selected portion of the component are to be carburized, the remaining portions are covered by copper plating. So, the portion which are not to be hardened to be covered by copper plating before immersing into the liquid bath. So the temperature of liquid carburizing vary from 840 degrees centigrade to 920 degrees centigrade. After carburizing is over, the components are removed from the bath and quenched in water, oil or brine. Some major advantage of this process are uniform heating, very little deformation of article, greater depth of penetration is possible. So next is gas carburizing. In gas carburizing process, the components are either suspended in the gas furnace from hooks or are heated in a horizontal rotary type gas carburizer. So the component is suspended in a gas medium. Hydrocarbon rich gases like natural gas, methane, propane mixed with carbon monoxide or carbon dioxide is fed into the furnace to create a gaseous medium inside the furnace where the component is suspended or it is kept in a horizontal position. To maintain a controlled atmosphere, there is a provision for exhausting the spent gases into atmosphere. After the parts have been soaked in the carburizing chamber, they are directly quenched without being exposed to atmospheric air. It is found that a 4-hour sitting in gas carburizing temperature of about 927 degrees centigrade enables a depth penetration of about 0.5 millimeter to 0.75 millimeter. The main advantages of this process are a superior surface finish on the component, controlled heating, accuracy of the desired hardened case depth. Next process is nitriding. Nitriding, like carburizing, is another surface hardening process. The introduction of nitrogen into the outer surface of steel part in order to give an extremely hard wear resisting surface is called nitriding. It is based on the absorption of nitrogen by the metal and no quenching is required. This process can be performed both in gaseous atmosphere as well as in salt bath. In gas nitriding, the parts are heated in an atmosphere of ammonia to a temperature between 480 degrees centigrade to 630 degrees centigrade and held there for a fairly long period for nitrogen to decompose from ammonia and to combine with the alloying elements in steel to form nitrides. It is used for various automotives, airplane and diesel engine parts like cylinders, sleeves, liners, etc. So with this, the surface hardening process is covered. So next video, I will summarize all the processes of heat treatment and what is hardenability and what is the difference between hardenability and hardness.